Hello everyone, this is the fourth tutorial, and today we'll be covering heat transfer of natural convection. We will model a closed box without inlets and outlets, and the bottom will have a chip. The dimensions for the box will be 200 by 500 by 500 millimeters, and the chip will be 10 by 50 by 50 millimeters. Let's switch to millimeters by pressing the button to the left of the Create Point button to simplify geometry creation. Create the points 0, 0, 0, then 200, 500, 500, then 0, 200, 200, and lastly 10, 250, 250. After that, we can create a small box. This can be done by clicking the two inner points using the box creation tool. Next, press the two outer points, also with the box creation tool. Now you should have two boxes. We can switch to wireframe mode on the right to see that there are indeed two boxes now. We need to create a single body, and we can do so by clicking the subtract Boolean tool on the left, pressing the large box first, hiding it, and then clicking on the small chip box. Let's turn off wireframe before moving on to naming of the surfaces. Now that everything is ready, let's start by naming the chip ceiling and walls for a total of 5 selections using multi-select, which is turned on by continuously holding Control and right-clicking each surface. Now we can name these wall hot. For the remaining walls, do the same multi-select feature and call them wall ambient. Now that all faces are named, we can press to mesh. In the Mesh tab, leave everything as default, but do change the refinement to a value of 2 to create a finer mesh around the chip. Then just press Generate. Now let's just check the mesh to make sure it looks good by using the cutting planes. And as you can see here near the wall, it has refined it further because we set it to refinement of 2. Now press to setup. In the Setup tab, leave the fluid and materials as default, but do turn on the heat model. Next, let's click on Wall and Boundaries, and choosing Wall Hot, set the wall type to Temperature, and change the temperature to 450 Kelvin. Do the same for Wall Ambient, but leave the default ambient temperature it provides. Now that the basic settings are set up, let's enable buoyancy by pressing Settings in the top left and clicking on Operating Conditions. Check the buoyancy box, keep the reference pressure and temperature the same, but swap the X and Y gravity values since the chip is located at the bottom. Then press Apply and to Solution. Let's create a monitoring point above the heat source at 0.2 for X, 0.225 for Y, and 0.225 for Z. Set the monitoring point to monitor temperature and then press Run. This simulation converged quite quickly since the case is simple. Now we can go to Result. Let's create a plane at 0.225 for Y. Let's set our plane to velocity for the variable to see the vector plot. As you can see, now we have the velocity plot on screen. Let's add velocity magnitude, and we can also check temperature also. As always, you can create a report if you'd like. That will be all for the heat transfer of natural convection tutorial. Thank you for watching and happy simulating.